In this video, we're going to answer this question here, which is to find the equations of both the tangent and normal lines to the curve y equals 3x times e to the power of x plus 2 at the point 0, 2. So the first thing we'll do is we'll find the equation of the tangent line. So to do that, we're going to need to find the gradient of the tangent line at the point 0, 2. So we're going to need to differentiate that function. So if we've got this function of x here, y of x is equal to 3x times e to the power of x plus 2, then, or to differentiate this part here, we're going to need to use the product rule. So I've got the product rule written out in the top right hand corner of the screen there. So if we take u as being equal to 3x, and if we take v being equal to e to the power of x, then we can go about differentiating that part there. So we get then that y dash of x is equal to, and we'll just look at this part here first, so using the product rule, so we're going to get u, which is 3x, times the derivative of v with respect to x, which is just the derivative of e to the power of x, so that is just e to the power of x, and then plus the derivative of u with respect to x, so the derivative of 3x is just 3, and then times v, which is e to the power of x, and then this part here, this plus 2, well, that is just a constant term, so the derivative of any constant term is just 0. So we get then that y dash of x is equal to 3x times e to the power of x plus 3 times e to the power of x. So now, just to simplify it a bit, we can factor out this 3 and the e to the power of x. So we get then that y dash of x is equal to 3 times e to the power of x, and then in the brackets we're going to have x plus 1. So we want the gradient at the point 0, 2, so that is when x is equal to 0. So at x is equal to 0, we have then that y dash of 0 is equal to 3 times e to the power of 0, and then in the brackets we have 0 plus 1. Well, e to the power of 0 is just 1, so outside the brackets we get 3 times 1, which is just 3, and then inside the brackets it's just 1, so this is going to equal 3. So we've got the gradient at the point 0, 2, and we've got a point on the line, which is 0, 2. So now we can find the equation of the tangent line. So just a quick reminder, in general, the gradient of a straight line is y minus y1 is equal to m brackets x minus x1, where the coordinates x1, y1 is just a point on the line, and m is the gradient of the line. So for our tangent line here then, we're going to have y minus 2 is equal to, well, our gradient is 3, and then we're going to have x minus 0. So simplifying this and rearranging it, we're going to get y is equal to, we'll add the 2 to the other side, and just expanding this bracket here then, we're going to have y is equal to 3x and then plus 2. So that is the gradient of the tangent line to the curve at the point 0, 2. So now we'll find the equation of the normal line at the point 0, 2. So we know that the gradient of the tangent line is 3 at the point 0, 2. So the normal line is perpendicular to the tangent line. So the gradient of the normal line is going to be the negative reciprocal of the gradient of the tangent line. So therefore the gradient of the normal line is negative 1 over 3. So therefore the equation of the normal line to the curve at the point 0, 2, that's going to be y minus 2 is equal to, our gradient was negative 1 over 3, and then we have x minus 0, so we have then that y is equal to negative 1 over 3 x plus 2. So we've got our answer to this question now. We've got our equation of the tangent line here and our equation of the normal line here. So we'll just bring up a graph of the curve and these tangent and normal lines, and we can see what they look like. So from the graph we can see our curve in blue. The y is equal to 3x times e to the power of x plus 2, and the tangent line to the curve at the point 0,2 is in red, and the normal line to the curve at the point 0,2 is in green. And we can notice that the tangent and normal lines are perpendicular to each other. And that finishes off this question here.